Erik Bryn. Yes.
Okay, so we're going to start the new session. Erik's going to take us through his, is that coding exercise, isn't it? His framework for developing Dapps and generalized state channels. And you've been doing this in collaboration with Counterfactual,
Yes.
what I believe.
Yes.
So take it away.
All right, thank you, Patrick. Hello, everybody. My name's Erik Bryn. I'm on the Counterfactual and Ember.js Core teams and the founder of Prototypal. So a little bit about me. I'm relatively new to the blockchain ecosystem. Actually, I think Liam and I are probably just as experienced, although I didn't go to college with Vitalik. But I'm a skeptic and a pragmatist, and I'm not a diehard libertarian. So this will be an interesting talk for some, maybe. I'm not a maximalist of anything other than shipping value to users. So what a funny place to be. I'm not a store of value guy, I guess you could say. So I've been doing open source development on the Ember.js team for nearly 8 years. And the Ember.js project is actually pretty aligned with the way that governance works for good or bad in the blockchain ecosystems as well, in the sense that it's decentralized. The Ember project isn't ran by any one company. We compete with projects that you've probably heard of, like Angular and React. Those are Google and Facebook products, essentially, open source products. Ember is a group of, we're nearly 12 or 14 people who work at different companies that work together to build an open source framework for building web applications in JavaScript. So it's been refreshing to be at an event where I haven't heard mentions of mooning and Lambos all the time, so that's also great. My experience is I help build applications for the web for companies large and small. Here's a few of the companies that I've worked with over the years. And so when I first, being somebody who builds applications for essentially Silicon Valley companies, when I heard about the blockchain technology, I remember acutely being at a bar in San Francisco, and I had a crypto friend who was like, Bitcoin, Bitcoin, Bitcoin. And I was like, I don't know, it doesn't seem like something that I should take too seriously. Probably should have bought some Bitcoin back then. Fast forward many years in the future, a close friend of mine was very interested in Ethereum, and he encouraged me to buy some ETH relatively early, and I just bought it and let it sit. And then more recently, in the last 6 to 8 months, he encouraged me to also get involved in the ecosystem and help perhaps provide some user value in the space. And so when I started looking seriously into blockchain technologies, this was my reaction. It's what a time to be alive, right? So having, basically, when you look at Ethereum or Bitcoin or blockchain through the lens of somebody like me, an app developer, you're just like, how the hell does any of this stuff make sense? Nothing makes sense. 10 transactions per second, 20 transactions per second. The tooling is awful. Like we think we're going to invent the Web3, but like the libraries for doing that are gross. You need to install browser plugins. Mobile is like all the rage, yet there's no story for mobile. And so it was very clear that blockchain is actually a religion more so than it is a viable technology platform. But I'm holding back. I'm trying to not make too many judgments, so I'm just trying to analyze and understand what's going on. If we can't really create any value, why are the prices so high? How do these market caps make any sense? And so thankfully, I had some friends that were more knowledgeable than I was, and they helped guide my analysis. And so they pointed me at payment channel and state channel technology, and I was like, oh, Lightning Network, yeah, great. This sounds interesting. And I read this blog post by Jeff Coleman. He said he expects to see Bitcoin payment channels within the next 6 months, but this was in 2015. What is going on here? So I keep trying to reach out, and thankfully, I've met a lot of great people over the years working on open source, and I had a good network. I could maneuver my way around and find smart people to talk to about what the heck's going on here. And so on that journey, I luckily got introduced to Liam Horn, who spoke before me at L4. And subsequently, after a trip to Toronto, I got to meet the godfather of state channels, Jeff Coleman, who's sitting up here in the second row. So we basically all got a room together. I was like, so state channels, how do they work? And I had a vague idea. I had done some research on my own and actually started imagining a protocol. And then basically I got my mind blown at the idea of generalized state channels as they explained it to me. And actually Tom was there as well at the same time. So Tom and I have been on this journey together as well. So, but still, I'm like, what the hell is going on here? But let's withhold judgment. Let's see what value we can provide. And so let's talk about the exciting technology that I've been working on with the guys at L4 called generalized state channels. So essentially, a really brief review of the things that Liam was talking about. The key thing to understand about generalized state channels is that we are optimizing for a minimal on-chain footprint. It's built upon a multi-signature wallet, as Liam explained. Counterfactual instantiation is a very important concept to understand. And there's object-oriented programming stuff, white paper. You can go read it if you haven't. But let's talk about how can we use state channels today. There's been a lot of talk and research published over the last several years, but it's pretty difficult for an average developer. I consider myself an above average developer, and I went and I read some papers, and I was just like, I don't even know where to begin. I mean, conceptually, this stuff makes sense, but how do you put the rubber to the road? I'm curious, how many of you here have actually built even proof of concept applications that use any form of state channels? Okay, so there's just a good amount, actually. Great. Maybe you guys can teach me some things. I'll try to teach you some things during this talk, but very few and far between. So basically, how could you use state channels today if you were here to leave and then go build a state channels app? I highly recommend looking at Force Move Games. It's not a generalized state channels approach, but it's very pragmatic and relatively easy to get started with. So we've had a lot of great presentations throughout the conference, but obviously, to Jez's credit, Funfair is probably the best example of state channels in the ecosystem today. I have a little demo, but I'm not even going to bother because they did such a great job talking about it already. So it's really hard to use state channels today is the TLDR. And we'd like to change that. And the we is the Counterfactual project. And the Counterfactual project is a collaboration between L4 and my company, Prototypal. And so we want to see generalized state channels exist in the world, and we're building a framework. It's going to be open source, holistic, meaning that we're going to cover the gamut of not just if you're a researcher in state channels and you want to play around and build things, but if you're just a normal web developer and you want to build your first app, we would like you to pick up Counterfactual actually as the entry point into Dapps development over the stack that you have today. And so, no, we're not doing an ICO. This is just good old-fashioned open source like I've been doing for the last 8 years nearly. So it gets my seal of approval, and Brett Rambo's as well. I love this GIF. So the Counterfactual frame, so like I was saying, the scope of our work, and actually Liam mentioned before, scope of our work spans from core research all the way to the user experience of not only Dapp developers, but also Dapp users. So it's extremely important, I think, when you're designing state channels that, and a framework for using them, to not only think about yourself building the framework, but to think about your users, right? Your direct users are your developers, but then also the tools that you give them impact the user experiences they're able to provide to their customers, to their users. So this is, I think, one of the great ways that I've been able to kind of provide value to the team. I'm not an experienced blockchain engineer, but I have been building web applications for a long time at a lot of big companies, and I have worked with great designers and have really high expectations for what the user experience of web applications or perhaps Web3 applications should be like. So in my experience over the years, I think the best way to build frameworks is to build applications and then extract the framework patterns out of them. And so that's what we've been trying to do over the last several months, was build example dApps that use these primitives that we envisioned, and we've been through a few iterations of this to much of my dismay. the contract layer gets switched out, and then I have to rewrite everything. Great, guys, thanks. Our first dApp that I'm going to talk about is called ETHMO. It's a play on Ethereum and Venmo. So this is a basic payment channel app, and it's trying to beat the user experience. It's not fully baked, but essentially the user experience of this dApp should be top-notch. Like, you shouldn't have to wait very long, if at all. Things should feel instant. You shouldn't know, if you know the blockchain's slow, you should not think you're using a blockchain application when you use ETHMO. And so this is kind of the stack of tools we used. I'll talk more about that stuff in a bit, but here's a quick, very basic run-through of how ETHMO works. So we have 2 instances of ETHMO running. You can see the addresses up in the top right corner. Essentially, you come to a user interface. It's very simple. You get a users list. It's essentially who's also got ETHMO open. You can choose that person. You'll get a friend request, essentially. You can be like, oh, yeah, I want to connect with this person and open a channel with them. You'll get an open channel now. You'll have an open channel in the list above. You get into this not very well designed, but functional screen of creating initial deposits for that channel. And now you'll note, it's worthwhile to note that at this point, the user conceptually, from their user experience, we use the term channel. We probably shouldn't from a UX perspective. Users don't care about the implementation details of our app using channels or not. But we're lazily creating a channel in this user interface to give users the impression that, like, oh, they've gone and they've done the work and now they can send money. But first they got to do initial deposits. And so it turns out in this system, when they do their initial deposits, that's actually when the multi-sig is funded. So it's like a lazy instantiation of the multi-sig. So basically one party funds 10 ETH, the other party funds 5 ETH. Then we can send money across and you'll see instantly the balances change, right? So this is the user experience that we were going for. And you can also instantly withdraw from the channel as well back to the wallet. So we're going to see ETHMO again. So I'm not going to go into too much more detail about it yet, but Tic-Tac-Toe is our next dApp. This one, little different. It's actually written by the L4 team. And so it was just vanilla.js, TypeScript, ethers, but otherwise same architecture, and I'll talk a little bit more about the architecture. And so this is just a quick video of, essentially, this is the presence that's like almost the equivalent of the user list. You can play, you can make moves, play the game of Tic-Tac-Toe. I'll talk a little bit more about this, but this communication is being facilitated by a WebSocket relay server. So this isn't truly peer-to-peer. This isn't using some kind of fancy state channel network. The proof of concept was to just have a centralized WebSocket relay that can transmit messages back and forth. So the game's over. So let's talk a bit about the lessons learned from building these 2 applications. So for me, it wasn't until I built an application that I really understood at a gut level state channels. I tend to learn by doing. That's the kind of person I am. And so it was really insightful to have that exercise. And so as I was just talking about, Tic-Tac-Toe uses a WebSocket relay. So did ETHMO. It was just a simple design choice. We're really interested in, and actually the way that it's architected is we could actually, the apps are agnostic to their I/O. You can swap in other I/O providers. And so essentially anything that follows an event emitter-esque type interface or a socket type interface, you can plug in to these apps. So future exploration will involve Whisper and libp2p likely to enable these things to actually be peer-to-peer. And on that topic, it's a really interesting form of web application to build these dApps because they're stateful peer-to-peer web applications, which is not a thing you really ever write in the web world usually. So what does that mean exactly? Well, it means that basically your app is both the client and the server. So in these simple implementations, you're not only sending requests to the other user, but you're receiving requests from the other user, and you have to be stateful not only at the UI level, but also at like the protocol layer as well. So there's also very interesting things of like, if you refresh the browser, or you close the browser, open it back up again, you almost want like like if you think about how web servers work, they're stateless, right? You can shut down a web server, you can turn it back on. Doesn't matter what state or what requests you handled in the past, but in these applications, you actually need to kind of like, when you kill the server, you need to kind of reboot it with all the state that it had before, because you might have had pending requests. And in fact, in state channels, there is no source of truth for the state other than the DApp itself or the client itself in these examples. So like, this is gonna get into our next lesson learned, which is like the most important thing for the user's safety when building state channel dApps is persisting the state of the channel, right? And so if you're building dApps, the best, and they're running on the web, you have web browser APIs like local storage, IndexedDB, WebSQL, cookies. But as you're probably aware, it's really easy for users to like just clear their browser history. And if you had some money in a payment channel sitting and you've just spaced about it, you've just wiped out the state of that payment channel, and now you're susceptible to griefing, essentially. So that's not quite good enough for production use, probably. The other thing is like, nobody likes, like we like the security of the idea that we have to sign transactions, but if you're playing a game, nobody wants to be prompted to sign transactions every single turn, right? And not only your turns, but like the other user's turns. So we took a very simple, somewhat naive approach with these dApps, where we basically, the dApps get their own ephemeral key generated. And so, and in fact, I won't go into much detail. They end up owning, these dApps that I showed you, the first iterations of them, the multi-sigs ended up getting owned by those ephemeral keys too, which is not a good idea, but it was just a quick and easy thing. But those ephemeral keys also become extremely important, right? Because if you lose your private key, you can't make any progress in the channel anymore. So those are both like critical things that if you're going to try to build state channel dApps, you have to solve those problems in a significant way. And so, from that perspective, it becomes extremely clear to me that the success of state channels is wholly dependent upon their adoption and standardization and integration with wallets, whatever that means. You want to like think of wallets as browsers or MetaMask-esque type things. I will go as far to make the assertion that, and that's obviously not only true of state channels, it's true for the Ethereum platform itself. Like it's a little cumbersome to communicate with the blockchain if you don't have a wallet installed in the user's browser. Where do the keys go, right? State channels need wallet integration. Hopefully that's not surprising to you guys. So what does that mean, though? Practically speaking, you need wallets to agree to speak the same protocol as your dApps state channels, right? So that is a very strong indicator that this industry should be working towards standardization, because if we're going to see this technology live in real users' hands anytime soon, we need to all get on the same page, because the wallets are going to start coming, and whoever has the implementation that wallets integrate with first is going to probably win. And unfortunately, and we really want to avoid the world of like best used in IE6, right? So if wallets and state channel implementations are fragmented, you're going to be using different wallets, different browsers for some dApps than others, and that's not the Web3 I think we want to see. So it's really important that we get on the same page about at least what the protocols are that wallets speak to dApps to enable state channels. So those are the dApps we built, but we wanted to come with a little more meat on the bone. So we've been working night and day, basically, and as of last night at dinner, we were sitting across. A member of my team back in San Francisco pointed out, hey, we got our demo done. So great, just in time. so this is hot off the presses. I'm going to show you a demo of multiple dApps running in a single channel. So this is multiplexing state channels built on top of the counterfactual generalized state channels framework. I don't know if anybody's done this before, but it's pretty cool. Now this demo is going to involve a little bit of setup. So what we essentially did is we took those two dApps that we built separately, and we put them in iframes on a web page together side by side. So this is that. And as my key insight that I shared before, like the wallets matter, and if you think about how do two different Dapps that run in essentially two different processes emulated by an iframe here, how do these things share a channel? Well, the answer is that the wallet provides the channel to the Dapps, right? And so we've emulated a wallet-like shell that these apps run in. So the parent frame where you can see that account drop down, that is essentially, there's a wallet, you choose which account is active, and then we have two iframes side by side, ETHMO and that Tic-Tac-Toe game, which are bound to the selected account. And that wallet actually does all the state channel communication, all the key management. The Dapps become dumb clients to an RPC, not all that different than the way you build Dapps with wallets today. So let's take a peek. I'll narrate this as best as I can as well. So I'm going to use ETHMO. We saw a little demo of it. So I'm going to find the other user, going to send them a connection request. We're going to switch over to there. I've got two browser windows running. I approve that request. Great, we have an open channel now. I can go in to that open channel. We can see the state of my account balance and the channel balance. I switch windows, go into the same window, right? I think I'm going to throw some, actually, I'm going to go to the Tic-Tac-Toe game. It did like peer discovery of the other players. So now we have the game and the payment channel Dapp running side by side. I think I'm going to make a deposit here. So we're going to put 2 ETH in this channel. We're going to switch, you can see, 2 ETH, and slightly delay the account balance. Async is a very interesting problem to solve in user interfaces here. So 5 ETH, we'll see the account balance go down as well shortly. And now I can also just like simultaneously be playing this Tic-Tac-Toe game. If we switch over, you'll see my move, switch back, make a move, do this a couple times, interweave some payment channel some payment channel operations as well. We see balances change, we make moves, yada, yada, yada. So we'll very quickly finish the game here, I think. And the cat will win. So unfortunately, one of the things that we didn't have time to implement here is actually when that game was won, you would actually instantly see the stake. There was a 2 ETH stake that was being played in that game. If I had balances at the wallet, at the top bar, you would actually have seen the balance increment in the winning player's wallet instantly as well. So what do you think? Pretty cool? This has been a lot of work. So thanks to my team and the L4 team who have been slaving away for the last few weeks on getting this ready for you guys today. So what's next for us, for Counterfactual? We're still in experimentation mode for the most part to build a holistic understanding of the system that, and we don't want to like be too, we don't want to oversell and underdeliver, which is perhaps a unique characteristic in this ecosystem. But before we start promoting specific implementation details outside the paper, we need to actually figure out what we want to propose. But good news, we're pretty confident our contract layer is ready for collaboration. So we released our paper on 6/12. We expect in the month of July to release our contracts. That's another really important point of interoperability. I think you could actually have different implementations, but a shared, ideally, protocol for wallets. But we would love, if you guys are working on state channels, we would love to have your eyes and your help with our contracts layer. So expect an alpha release in July. And then there's this JavaScript framework. This is probably the least baked of everything, and I'll vaguely say next few months, and fingers crossed. Counterfactual is an open source project. It's not just, I want it to be ran in the same way that the Ember project is run. I want it to be a collaboration with multiple teams from people of different backgrounds that makes it a better project. I think we need to, and I'll keep pushing. I think we need to get standardization in the space. I don't want to like say that we shouldn't have competing ideas and competing thoughts. I think there's ways that we can find standardization efforts at different layers of the stack to enable us to actually start building state channel dApps sooner rather than later. I think it's really important for the ecosystem. And so we would love to have you guys work with us. Everybody from researchers to wallet developers to dApp developers, please reach out. Thank you very much. That's my talk.
That was awesome. I love the live demo. I was hoping for the CryptoKitty to win. That makes me happy.